Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. That's what we're doing today, right? I believe so. What is up with my capture here? On today's episode of Ferris Has Difficulties. No, it's fine. Oh, that's what it is. I'm crooked. Anyway, I think I'm actually too big now. Ferris has hugs. I like that idea. That's always what it is when all commas around. Hi guys in the chat. Cyberpunk Alkama again. Thank you so much for the sub. Trey Guy, Whister Tube, Aaron the German, Pakal. Hi. Man, I gotta be honest, you guys. My head has been all over the place last couple weeks. I think it's a mixture of things. I know for one, the staying at home and working all the time is definitely part of it. I've also just been like doing a lot of stuff. I've kind of been trying to take advantage of the situation and just work on as many things as I can, and especially coming down from revision. Even though I didn't really have any productions or anything, I just felt like I was inspired and wanted to do a lot. And also giving the talk on the compressor made me kind of revisit some of the stuff there. So I actually made some improvements that save like a good few hundred bytes on every intro. And I just put out a new version of the packer because of that, which I'm really happy about. I found some other things today that are going to help, but are going to be like a memory versus compression trade-off. So I might hold off on some of those until we get 64-bit working, because then we can afford to waste a bit more memory. But yeah, we'll see. Anyway, so that's one thing I've been working on. The other thing has been the demo tool, and I started working on demo tool stuff again. I think the week or weekend before revision. Before that, I've been doing a lot of FPGA stuff, and then as revision came around, I started getting inspired and kind of switched gears a bit, which I'm pretty happy about. Doing some stuff that I wanted to do for a while, but at the same time, I don't really like doing a lot of this demo tool work. I've never enjoyed it very much. It's nice when it starts coming together. I can show you guys some of what I've been working on, but I find it ridiculously boring. So if I don't seem very enthusiastic on these streams, that's just how it is. And I'm kind of just pushing through it because I know I'm really happy with what I'm making, and I'm really happy that it's starting to work. So I'm kind of just trying to use that as motivation. I've been watching a lot of motion graphic stuff and getting inspired for things that I actually want to make, which is really nice because then I kind of have some idea of where I'm going with this tooling. But right now, regardless of where I'm going, there's this period of just doing stuff, and you can't really get around it. So I'm just kind of fighting through the pain. But I'll show you guys some of my progress. Yeah, it definitely will help, I think. I think it's going to be really great when things start working. So actually, this is the tool I think I've shown basically this for a little while now. I actually want to rearrange things. I haven't done this in the code, but I want to rearrange things for how I think I want this to all be laid out. You can see I don't have the style and Qt all finished, so there's some of this crap. But I think actually this is sort of the main layout that someone's going to see. Nodes are a bit big at the moment. That's actually because otherwise they're really annoying to click. So I might change that, but we'll see. Yeah, I went back to the normal setup today, much to my own dismay. So here there's a sequencer, and I think it's going to end up being here because I think most of the time it's not. I mean, of course you can move windows around, but I think the typical layout's going to be like this, where you have the nodes here and we have the inspector on the right. Maybe even the profiler is going to be hidden by default. I'm not actually sure. Whoops. Okay, can't really dock that the way I wanted to. Oh well. There we go. And you'll notice the screen is empty. This is actually the Dope on Wax project with a couple modifications. So it looks like it's all empty, but it's really not. And again, I still have like the operators and stuff. They're just not shown right now. So anyway, I have these nodes, and I don't actually know if I showed this last time. But there is a big difference, and now that the nodes actually are starting to have a working inspector. So this is the node graph, and this is a scene. Oh yeah, I can actually move these now. Did I have that last time? I think that's what I was working on last stream. I don't remember. But yeah, I can move these around now. I can overwrite stuff. And so this is like the root node. This is a scene. This is a cube. This is just some test data. None of this actually gets saved right now. And then here's a transform, and here's a material. And notice the biggest difference now is that there's actually editors for some of these properties. So if I have to mess with the material because there's no lights in this test scene. There's just a cube, which is literally this node. So I just change this material to change its emissive properties. I can click around. And then if I go to its transform, for example, you can see I can change its X position, for example. So not much. And these editors are not done because like it works to like click and drag, and it works to actually show the value of the property, which is really nice. And of course, undo and redo all work, which is obviously necessary for my workflow. It's also very fast, which is really good. I hope that continues to scale well. But you can kind of see at least how this basic scene will be built up. Of course, this is going to get a lot more complicated. Particularly, this is like the simplest kind of material. And I want to also expose inputs here so that you can either use this property, or if you connect an input, that will override the property. And then you can use the nodes to create more complex expressions for these, which I think is gonna work. Yeah, it actually has the full rendering pipeline in addition to just Bloom. Of course, you see the bloom now because I'm the way I got the cube visible instead of adding lights to the scene, which I can actually create new nodes, but I don't have a light node yet or a way to connect the nodes. I haven't added that to the editor yet. But yeah, so the way I made this visible is just to make it emissive. And so then, of course, you see the bloom. But it does also have the depth of field, and like it has the whole renderer in Dope on Wax still that this is going through. It's just that now the scene itself is defined by the nodes here. In fact, I think if I go on the operators, yeah, I just straight up deleted all the calls to the other scenes and the camera stuff. That's funny. So all the scenes are still there in the operator grid, but not being used right now. Yeah, and I can of course change that. And eventually, like, this is 3 sliders, which is already better than what I had before is 3 text editors. Because I also added editors for string properties, but there are no string properties in any of these nodes at the moment, so you can't really see that. Except I want to expose, like right now, nodes have names and then they have additional properties, but I think I'll just make the name a property that every node has. Because I think that'll make more sense. And then I only have to do the stuff that I would do to edit string properties anyway. I don't have to do additional features to edit the name of the node. I can just use that during compilation and special case that to display it here. But yeah, I mean, it's pretty straightforward, what I have here. And I think this is going to work quite well. I need to like categorize the nodes. So the nodes themselves, they have like a list of properties and a list of inputs. I need to also generalize the notion of an output. Right now, they only have one output, which is itself. But I think I want to expand that potentially. And so nodes, a node has like a type, and then it might have things that are connected to it if the connections are hooked up. You can see there's little tooltips for like this represents a transform, this represents a material. So node has a type, and then it has values where it fills in. So like the type defines properties and connections that the node can have. And then types are also checked. I mean, they're not actually checked now, but the point is that they're going to be checked. So when you try to connect things, it'll do a type check and make sure that you can actually do that. Or if something ends up being connected that doesn't type check anymore, because eventually the types of the nodes are going to be dynamic, then it needs to be able to show an error in that case, but you still need to be able to modify those connections. So stuff like that. Anyway, so the type just defines like which properties there are. And that way, with like a type checked graph, you know that when you compile these nodes, you know which properties these things are going to have, so you can compile them correctly. Additionally, I'm adding the concept of traits, and traits is only like a node compile time feature. I think the editor will have to know about it because some of the like input ports are going to like you define a type that they can use, but I think I also want to define you could use a type or a trait. And a trait, all it really is just a list of like required properties and ports. So it seems a bit odd maybe to have that in addition to types, because you could like use inheritance, but I think I generally don't like inheritance. So what I would rather do is say like you use types as an additional compiler time checking mechanism to ensure that the type that you say a node has, if you say a type implements a trait, then you need to provide all of those. That type needs to provide all of those properties and ports. And I think that's generally going to be a good way to do that. So yeah. And then of course the compilation right now, whoops, it looked like I just had something dropped out really quick. Let me see. Hopefully you guys didn't see that, but I'll double check anyway. And yeah, the compilation for the nodes, in addition to the types and traits and everything, that's all going to be dynamic right now. It's as part of the tool code, but that's going to be dynamic. And I think I'm going to actually do that as pulling in a separate Rust project now that I've started doing that compiler stuff in Rust, because it's really easy to set up tests for that. I like the extra type checking. So I think that'll be fairly nice. It does mean that everyone who's going to use this tool needs to have Rust installed if they want to change it, which, at least for me, that's going to be a central part of this workflow. But for example, Hoffman, he probably isn't going to do that much. So it probably isn't going to matter. But yeah, so part of the project is going to be a little Rust project that defines, that gives a method to get the traits and the types, and then another method to actually compile a graph that's been type checked by the tool already by the time compilation happens. Or maybe not. I might actually just offload all of that. We'll see. So anyway, it's starting to come together, even though this is like really basic kind of scene here. At least it's sort of tending towards like a good enough sort of proof of concept to me, at least. Although I don't have most of the useful nodes and everything set up here, and I don't have the live reloading of that compilation project. Again, it's still in the same project. So there's a lot of things left to do. Again, I have no way of editing the connections. The only way I can modify the connections right now is by overriding nodes with other nodes that then breaks the connections, which is obviously only destructive and not good. But it is starting to work. That's kind of the exciting part. No, I won't use the Rust compiler itself. This is all kind of weakly typed as far as the Rust part is concerned. It's its own little type system and everything for this node graph. And compilation feels right now pretty weakly typed, but I think that's going to be fine. Like the key is going to be that I can make new node types for specific effects and everything, and that should be part of the project, not part of the tool. So it's kind of trying to decouple that a bit. I'm feeling less allergic to giving the tool knowledge of things like cameras, for example. But for example, material it's entirely dependent on the renderer that you use, what that means. I think generally a demo is going to want to know what a camera is, for example, but I think it's unlikely that we'll use the same material system for more than just a couple demos. At least that's been our experience so far. So that's kind of, I guess, a good way to determine what we put in the tool and what we put in like the project, if that makes any sense. Anyway, today I wanted to continue on these property editors actually, because right now you'll notice, or maybe you don't notice, because I know the font's kind of small, but that's just how it is in the tool because that's how I want it. But these sliders, they all go from 0 to 1. And there's a couple things here. First of all, I want to implement like a double click so that I can go and type this value instead of only being able to drag it. So that's kind of one thing. I think I'll do that later because I know it's going to be really boring and just me Googling cute stuff a lot. The other thing, though, is that they all go from 0 to 1, and it will check those bounds. And generally, that's like in the property definitions, I want to be able to define if these properties should actually be bounded and what those bounds are, and then expose it to the tool, and then the tool can optionally have those kind of bounds. So what I'm thinking is right now, like these are, for example, the metallic parameter in the material. This makes sense to be bounded between 0 and 1. Same with roughness. So this does have the correct behavior, but then if I look at the transform, you can see translate x only goes from 0 to 1. Obviously, this is one where I would want to have a much larger range. And that's kind of the other reason why I want to wait to like double click to edit these values, because I want to have the range checks available in the tool before I start writing that code. But yeah, so in a case of like transform like this, instead of being bounded, the behavior I think I want is I want the slider to always be like in the center position, which represents the current position. And then when you click and drag that, it's going to be relative to that, and you can drag past the edges. That's what I think I want. And then when you let go, it'll reset to like the middle, because it'll make that sort of the new center value. So that's what I think I want for unbounded properties. And it might be enough to only have bounded and unbounded. I've been thinking a bit about like if I also want to do like be able to determine either unbounded, only lower bound, only upper bound, or upper and lower bound. And the other thing is like an unbounded property also needs to know kind of what range of values it should have when you're actually clicking and dragging. So I think I'm going to need to think about that as well. Like I can think of, for example, for a light, it makes sense to modify its color, which, by the way, that's another thing, is this emissive color right now is 3 sliders. I think ultimately what I would want for emissive color is two things. One is I want to have like a color picker, like color wheel kind of thing, to actually pick the color, and then another slider for like the emissive sort of power. And that emissive power, generally I would want to only be positive, for example, but I want it to be unbounded in that direction. So that's a case where I would only want a lower bound. And I might also want the slider to, instead of going from 0 to 1, I might want it to go from like 0 to 2, because I like to have emissive things be really emissive in my experience. So it makes sense. Cyberpunk also mentions like nonlinear scales. That I actually haven't thought about that much, but I think that would make a lot of sense, especially for things like exposure. So yeah, I think that would be a good thing to add as well. I think I'll put that one on hold, but I'm glad you brought it up. So yeah, so at least I want a way to be able to determine the bounds, and I think I'll start with that next, and then get these sort of slider, these slider interactions working with those bounds. Again, I find this stuff really boring, but it's really necessary and it's really important, because I'm kind of putting a lot of money on this node system, to put it one way, because I think ultimately this is how the other guys in the group are going to be using this tool, but also it's how I want to use this tool, because again, this operator grid works pretty well for low level stuff, but it just ends up being too many operators. Like this is to render a single solid. There's just a lot of operators, and modifying single properties here is really painful. So we want to have a better way to compose scenes. And I've been thinking about, like, for example, a better material right now. This, again, a basic material, but like a custom material, or if you want to like override any of these parameters, then I want that to actually generate shader code. And that will then use, I guess, like some kind of basic value node, which those value nodes might mean different things in different contexts. They might be compiled to expressions that run on the CPU, or they might be compiled to expressions that run on the GPU. And that compilation obviously depends on the context in which it's compiled in. So like the compiler itself is where I think all that complexity is going to live. And I feel very comfortable with that approach, because I like working with compilers, and I think that's going to be very testable. So I imagine that the node graphs I have are going to be very, very well tested. And then whenever I add new kind of nodes, I just kind of plug them in where I want them to be plugged in. And yeah. So anyway, I think this is going to be a great approach, but I have to do all this basic stuff like being able to edit the values on the nodes, and that has to be rock solid for this to be at all useful. Mad Triangle, is this Rust? This UI is Qt and C++, but all the data model and everything is Rust. Code Charter says, will the parameter values of the nodes, will you be able to change them over time like automation? And the answer is yes. So what I want to do is add a node to say like read a sync track, and then that will read one of the tracks from the animation editor. So it's going to be fairly loosely coupled in that sense. But yeah, that's generally how this is going to work. I did I think I did a stream where I started working on the sequencer again, and then I kind of put that on hold because I realized that I wanted to get farther with these nodes to see kind of how the two pieces would fit together. So it seems on one hand it feels a little scatterbrained to kind of work on both at once, but on the other hand I felt that it was actually a better idea because I wanted to be able to start composing scenes in here, even just test scenes, and being able to animate them. So to me it made sense to kind of have this in place and more solid before working on this again. So that's kind of where I'm at with that. But yeah, I mean, I think this will work well. Again, already I feel quite happy seeing even just this basic editing here. Because if I show you some of this compilation, I think my setup's all dumb right now. Let me just, can I just like close all? I have so many windows open. Whoops. Oh, that's something else. Got some other notes open in my editor here. That's kind of funny, actually. This is what I want to show, but I need to close everything else too. Yeah, reorganize a bit here. Here we go. Let's see. Then right now it's a mess too, where all the different code is, but that's how it is right now. Okay, let me bump up the font size too. Okay, almost there. Okay, so here's where I have the node definitions right now. They're kind of verbose to write, but not too bad. I imagine this will be really easy to split up once I have everything in place. But the idea is that like here's a root node, and it's got like a scenes port, which those things are type scene. I think this is a list of scenes is the idea. Scene has a list of entities in its entities port. You have a cube, which implements the entity trait. And I don't think I have traits actually defined anywhere because I hadn't figured that out when I started writing this. And then entity, or a cube, has like a transform port and a material port. And then it expects those are hooked up. Oh yeah, that's actually done now. As it's going to be. And then yeah, this transform just has these different properties. And the properties, of course, have their type and then whatever their default value is. And one of the compilation steps is going to be to check the type definitions themselves to make sure that like the default values and the types line up. Actually, if I make default values required, I might as well only use that to get the type as well, but we'll figure that out. And then yeah, materials, in this case, again, just these properties, albedo and all the things you'd expect. So the idea is that I would make one function that would essentially export exactly this. Right now the test node is again just at this position, there's this node, and then sometimes it has connections to this port, connects to a node at this position. And then of course there's a node there. But of course this won't be written out. So I'll have a function that does this and another function that represents the actual compilation of the nodes, which is right now here. And then this will just go through the ports and compile them. And the reason I wanted to show this is things like the material right now just emits operators, like you see in that other editor. So it'll emit a local declaration for the variable albedo red, which it gets by taking the property albedo red from the node and then converting it to a string for that operator. So it just outputs all those. So that one node represents these 8 declarations. And then a cube, for example, will compile its transform and its material ports, which will just set up all these locals. And the locals for the transform just makes one local that's the new world matrix where it has this expression that's then compiled by the operator compiler. So already here you can see that like in this case, this one node fans out to multiple operators, and this other one, it fans out to one operator, and then this is a different kind of operator. So it's very freeform how the nodes get compiled to operators, and that's kind of the whole goal behind all of this. That's what's going to make this really flexible. And then for ones that are going to do actual compilation of like shader code, I'm going to expose a new kind of operator, or maybe just extend the operators that I already have for representing shader programs, and then give them expressions that will just contain raw code. And so then I'll just dump that as a string, kind of like I do here. So yeah, I think this is going to work really well. I'm feeling better and better about it as I keep going, which is really nice, because sometimes you get halfway through implementing an idea and you hate it. But that's not the case here. This actually feels like it's going really well. That said, again, a lot of work to do. So we'll continue on that. So yeah, so bounded properties, that's what we want to work on. So the actual node definitions here, move some stuff around. So yeah, these are the structures, and these structures are going to live in the tool. You again have node type, and that has the traits that it implements, which again, traits are not actually defined here. So I need to work that out too. But yeah, it has the traits it implements. It has the properties that are here, and then the input ports that are here on this node type. And then this properties is this property. Property has a name. It has the type, which is property type, and then default value, which is property value. Again, the type float 64 in string. And I think what I want to do is add those attributes here. I want to add them to the type. Right now, this is a simple enum. And I think I'll just extend these with additional data. So if I did this, it would be float 64 attributes, for example. So then here we would have, this needs to derive clone because its parent does that, and this will be pub enum these attributes. Actually, this will be struct. No, it will be an enum for now. Ooh, I'm welcome to changing this. Let's see. So I want, let's see, this is either going to be unbounded, or it's going to have, would I say lower bounded? Or actually, let's do this. We'll do bounded lower, and then bound is 64. And then we can do bounded higher, or upper, that's what I wanted to say. And then bounded lower upper. So if it's bounded, the slider range is going to be determined by these bounds. But if it's not, then we need some additional thing here. So this, I guess it'll be editor range. And all these unbounded ones. Yeah, so this is complete, is the nice part about this. These are all the cases that we have so far. And if I wanted to add like some kind of nonlinear mapping, I would probably, instead of having attributes like this, I would probably fan this out to be another enum that would be the bounds. And then also have like a mapping field on there. Maybe I'll do that actually. Property bounds. Oops. No, it's this one. This UV struct. I've embraced more of this like named parameter style, even if I only have one parameter. I didn't used to use that a lot, but I've been using that more recently as I've been doing a lot of Rust. Not everywhere, because like in this case, it's very obvious what this parameter is going to be. But yeah. I think I like that. And then these definitions that I have need to actually use them. I think right now if I just try to build it, it should give me compilers about that, which I'm going to do because I like to see those before I make changes. And today I'm listening to, actually for a while I've been listening to Noisy's Outer Edges album, which I haven't listened to for a few years. I loved this when it came out and haven't listened to it for a while, but I've been falling in love with it again recently, so that's nice. Oh, this... I need to actually check something. No, that is the correct Rust version. I don't know why it's rebuilding everything, but fine. Oh, probably because I updated. That's what it was, I bet. Because I updated my Rust toolchains because I packed up a new squishy release, so that's part of it. So my stream's about to get real jank now that we're building everything. And I'm just fine with that. Real jank. I don't know if you can hear me, but if you can, hi Zokwar. There we go. There's all the errors. Perfect. I'll wait a minute for the stream to kind of catch up. What a pro. By the way, I've been delighted about the response to the talk I gave at Revision about compression stuff. And a couple people have sent me like questions asking more details about that stuff, and I have loved answering those. It's like the best word I have is it feels like decompressing because I just like loaded my head with this stuff up the last couple of years, and it's fun to talk about it now that people are also interested in doing their own packers, which is really nice. Yeah. Yeah, so here's property type float 64. And then here we can do the attributes. I think this is qualified in this scope right now. And this gets so verbose the way this is written right now, but I don't really care about verbosity here because that doesn't really, it just doesn't really bug me. Like if it's strongly typed and I know that the compiler's checking all this, I don't really care that much about things being verbose to a point. So translate x should be unbounded. And yeah, also this is written wrong. This should be property bounds unbounded, and then editor range, I don't know, 10. I don't know what get bounds for these are. That's going to take like trial and error. So yet another reason why I want this reload to be separated from the tool eventually. But for now, we don't care about that. We just want to get things to build. It's like Y is going to be the same. Z is going to be the same. Rotate is going to be the same, but I think I want a different range. So I don't know. Let's do like 2. I think these are in radians right now. And I might also want to make those degrees, which is probably more natural for these parameters. But I'll just keep them as they are for now because it's easier. So rotate Y, rotate Z. Scale as well. I actually want this to be unbounded because negative scale might actually make sense. I don't really think it does, but it might. And actually, scale's a really good case for nonlinear editor, or for nonlinear slider. But I'm going to ignore that for now. I'm just going to build this again to make sure that I get rid of those errors. Yeah, this looks good. All right, so albedo red, this needs to be bounded. Bounded lower upper, and this is going to be lower 0, upper 1, like that. And we're going to have the same for albedo green and albedo blue. And I foresee that like when changing this stuff, of course, like these bounds need to these will generally be coupled with changes in the node compiler as well. So it might be that the way I organize parts of the compiler is I sort of organize parts of the node definitions with the parts that compile those, but I also imagine there's going to be a lot of intermixing of those kind of things, as like a given node might be compiled in a few different contexts, slightly different way. So it's probably going to end up just being pretty messy, which is fine. It's not about making something that's always simple. It's about managing where the complexity is and making sure that if there is complexity, it's sort of sensible complexity, if that makes any sense. And that's how I see this, at least. So emissive ones, I imagine bounded lower is what I want. It might be I'll make this 1. I think that makes sense for emissive. It might be actually that I want to allow negative emissive for some materials. So I might change this later, which again is another reason to have this compilation be part of the project. I might change this and something else might make sense, but for now I think this is what I want. And then again, we're back to properties that need to be bounded lower and upper. So metallic here and roughness both need to be bounded. And now we're going to build, and it's going to take a minute. Or not. What did I mess up? 535. Oh, that makes sense. You know, I might be able to get rid of these clones now too, which I think would be nice. I think that's actually the only place we're cloning this. So what's happening here is this is part of the code that exposes these parameters to the actual tool. And I'll just show some of this. That's going to be in here. This was 535. Yeah, this is the function that gets a node type's properties type. And before, since that type was a simple enum, the one we just changed, now it's not, so we can't just convert this trivially to an integer. So we need to actually match and do the different ones here, which is fine. Now I just need to add some stuff here. Constant. What did I call this in the C side? So we're just going to copy these. Property type. That's what I call them. So now what this needs to do, this needs to match this. And this will be nodes. Property type float 64. Something like that should do it. And I think this will then work once it builds. Of course, it won't actually do anything with those bounds. That we still have to do, but at least all this stuff should work. Yeah, that's what I was going to mention. So another reason why I kind of want to work on this tool and why I don't really mind not working on the FPGA stuff is that, like, obviously there's still a lot I need to do on my FPGA, but eventually I want to make it. I've been calling it games console, but a friend of mine, since I only ever really want to make demos for it, he said, why don't you just call it a demo console? I love that idea. So I'm totally going to do that. So I'm working on my demo console on my FPGA. And there's still a long ways to go with that, but eventually, again, the goal is to make a demo on it. And so a lot of these editor features, like, again, having a really general node graph that might compile to something else. Like, I want to kind of fork the tool and repurpose all of those editor features for eventually doing a node for or a demo for the FPGA as well. Not a node, many nodes. So again, I think it makes a lot of sense for both projects to sit down and do this grunt work of actually making all these editors work. So the fact that it knew all these were floats is a good sign, but of course it doesn't actually respect the new bounds. So we need to expose those too. And this is the annoying part of at least the way I've exposed everything to C++. It's all very, very much by hand through the C API. I've actually considered generating some of this code, but I think it's just dealing with it has actually been okay. So I'm going to continue to do that. Anyway, what I like to do with this is I've segregated a lot of these interfaces now. So if I look at for example, the inode model, this is a C++ interface. I say interface because it uses the sort of C# notion of an interface here, but really it's a pure abstract class. And the idea here is that this is the interface you would sort of code against if you just want to do queries on the model specifically related to nodes. There's also iModel, which again is this is going to be segregated further. This because it used to all be iModel, but now I've sort of separated different parts from this interface. So this eventually will become iOperator model. So you can see it has all this operator stuff here, but it also right now has some sequencer stuff, and that needs to and some error stuff, and both of these need to go onto different interfaces. But I haven't done that yet. And then there's going to be, there's iProfiler event list. So the profiler things that goes through this one, even though eventually all these are implemented by the same object that exposes all these on top of the C API. And that gets, like, I could just use this directly everywhere, but this gets kind of unwieldy to look at and use. But it makes sense that it's all together as one implementer. because it's exposing stuff from a C API. So like it makes sense to kind of gather all that on there, but I think it also makes sense to have this extra layer that kind of segregates all these different things. And it's literally just putting up walls for walls' sake. A lot of guys, at least in the circles that I'm around, don't really like when you do this kind of thing in C++, but I just think it's really sensible in this case. Anyway, it makes sense to me, so I'm doing it. It's my project. But yeah, so this is the inode model, and here you can do things like get the node type property counts, and then for each property you can get the name and the type. And here, this property type, we need to fan out the interface here to be able to get the different data. So the thing is here that this kind of starts to break some of the safety, because when we get a type, then we want to start like actually accessing some of these fields. So I need to look at the type, and then I need to be able to get its attributes type. So we'll add a method for that, and then we'll add a method for getting the bounds type, and then we'll add a bunch of methods for querying the different fields on the different types of bounds. So it's going to end up being I think like 8 methods or something that we need to implement, but it's going to be like trivial to implement all of them, except we have to implement them all the way through the stack, which is kind of annoying, but it'll work. Again, this is one of the reasons I've decided to do this kind of editor, is that we don't have to do this very many times, and once it works, we're kind of done. So I'm okay with living with some of this pain. SK, that's a kind of random question that may have been answered before a lot. What font do you prefer for the tools we create? I don't think that's been answered at all, actually. That changes over time, though. So in fact, I changed the font in the tool recently to, let me check the commit. Yeah, it's called input mono. I'll pull up a link. It's this one. And just the normal mono one for this, I really like. And I found that because there's someone, or it might be a collective, I actually don't know. But it's called 100 Rabbits. Again, I don't know if this is one person or a couple people. I think it's actually a couple people. And I like the aesthetic of the tools that they make. And they use, I believe this, for example, is the same font. You can see, if just looking at the visual style here, I think you guys can understand that I like this. It's very consistent with a lot of the things that I like to look at. So obviously this caught my eye. In fact, my presentation from revision straight up stole this color scheme and font. So that's kind of fun. Yeah, I'm glad you think so, SKTS. I think so too, and I think it's important to actually spend some time on that stuff. At least it's important for me. It probably isn't important for everyone. If it's not important for you, then you're lucky. But for me, again, it's important. So, as I'm sure you understand. And that's also why I spent like time doing the theming for this, right? And also one of the reasons I'm not using ImGUI. Another is familiarity. Like I just know Qt, so that's fine with me. But yeah, I do spend time getting like the colors and this stuff. Like they don't have to look perfect, but they have to look good enough that I feel good using this tool, which I think so far I've succeeded with. But yeah, the look of the tool has changed over the years. Before that, I used Menlo, which I think is the default monospace font on Mac, which is, I think, where I was exposed to that font in the first place. So the earlier versions of the demo tool looked pretty different. This is an earlier screenshot of demotivation. This is kind of cool. So this was demotivation in 2016. You can see I hadn't finished some of the theme stuff that I later went back and changed. But even here, there was a dark tool. This is also running on the Mac at that time. The operators, I think, are even smaller than this now. And yeah, that inspector was at the bottom. I didn't remember that. moved it up top at some point. These are earlier. There's an old blog I used to run called Every Weeks with some of my friends where I'd write up what I did every week. I don't do that anymore. I haven't since end of 2017, it looks like. Here's some fun Packer stuff, actually. What was I going to show? Yeah, I think this is just more early tool shots. This is before I colored the operators. Let's see. Yeah, I wanted to show one of the tool actually before this. So the very earliest incarnations of this tool looked like this. This would have been literally 4 years ago now. And you can see I was going for a more node editor approach inspired by Cinema 4D. So this was a literal node tree, and then I had properties like an inspector here. And I don't remember why I went with the operator thing. I think because I hadn't considered this plugin compiler approach. If I had considered it, then I think I would have done it sort of the way I'm doing it now. But instead of nodes, I would have had like this sort of tree view for the nodes instead of a more general boxes and edges kind of graph. But I think I like the approach I'm ending up with more, actually. So I think it's working out. But yeah, it was a bit different. Here I got nodes working, and I made a smiley face. That's fun. It's fun to revisit this, actually. And when did I give it that initial facelift? I think even here it's still... No, here I had the nodes colored, the operators. You can see this is right before Elysian, because this was the one that teased it, I think. And then, yeah, Elysian happened. And then, when did I do that facelift? I think it was one of these. I know I added the profiler while working on Engage, which was really helpful. Yeah, it's here, even. So I added the profiler. And that was, again, because I was working on the render a lot, and I was really concerned with performance. I was really glad I did that, because there were some parts of the pipeline that were a lot more expensive than I thought. And then, yeah, I think this is the facelift one, maybe? Yeah. So this was, well, I don't know when it was. Late 2017, I guess. And here, yeah, I did more of the theme stuff and ended up drawing the nodes, or the operators, how they are now. I still had the inspector below here. I don't know when I moved that, but at some point I did. Was that here? Is that the sequencer? Yeah, it must have been between there. This, I think, also was late 2017. And then the tools looked exactly the same for the following 2 years. Do I keep a mental list of UI that made sense when I implemented them, or are you following a more traditional design approach? In short, do you think beforehand or just whatever happens? I mean, I think a lot about this stuff. And especially now that I knew that I wanted a node editor, I thought I did a lot more thinking than coding. And now I actually have a list of, like, this is the ticket for it. And I actually wrote this the week of before revision last year, because I was so frustrated with working with the tool as it was then. And I started thinking, like, man, how am I gonna build a tool that's actually gonna help? And then I thought of that node compilation thing and wrote all this up. And then went through a couple things where I kind of imagined how the data model would look and what different nodes might look like. And this is pretty similar to what I have now. I mean, I discussed it with a bunch of people at revision and then decided I might want to use Lua. And then lately, 5 days ago, I started this comment, which is like a list of things to implement while I work on this. And I think when I had, when I was implementing the operators here initially, I had the same thing. Maybe it was a tweet that I sent out that had the same kind of list. I don't remember. Hey, here's another one of these earlier shots of the tool. But no, I did draw pictures of this in my notebook and kind of think about what it was. Again, the layout here is totally Cinema 4D, which I was really inspired by guys like Beeple and stuff. So if I pull up a picture, it's just a Google search of Cinema 4D images. And here you can see this is the node editor, or like the scene graph, and then here's the inspector, and then here's like the viewport and everything, and other like material editors. So I knew I at least wanted to start with that. And then it was actually around this time, this would have been summer 2016 is when this screenshot is from. And at that time, I was really unhappy with this approach, actually. And I think it was because I felt too locked in, and I didn't want to rebuild the tool every time I wanted to change the nodes, which I was doing all the time. So instead, I wanted to do like a lower level VM and then have an editor that targeted that. And it was when I was talking to Blueberry of Loonies that they had something very similar to that in their 4K tool. And that also has this kind of operator grid. Let me find that, actually. What was the demo they came out? Because they had, I think it was called Candy Stall. This is like 12 years ago. And they did a really good write-up about it that has pictures. Here we go. So this is the Loonies 4K tool. I can post this write-up for you guys. Actually, this is even earlier than that. I think this is 07. Yeah, Assembly 07. And their tool's also interesting in that they have these pretty generic operators that, have connections. Even, in fact, more open how they connect than in demotivation. But the idea here is that these have the operators and then they have the expressions. You can see this is at the bottom too, so I definitely copied this idea. And there's repeat nodes and then some variable declaration nodes and all kinds of stuff. So the sort of base set of the operators that this has and the base set that demotivation ended up with initially are very, very similar. They also actually will, instead of this being a really general VM that can kind of support everything, which is the approach I went with demotivation because it's a 64K tool. In 4K, you often need to really limit the kind of things you do. So you'll handwrite a specific renderer and then you'll expose a way to work with it via properties in this case, or via operators. So what they do is they, again, write a specific renderer and then hook it up to this a certain way and then have this, I guess, again, compile down to some way to use the renderer. So I kind of copied that, but I decided to have a really general purpose VM that everything was built off of and then build everything in this operators. So I was going for this after that, and that's why at the time this is basically identical. And yeah, it took a few weeks. I'm actually glad I looked at this now because I've been feeling like it's been taking forever to write these, to do these nodes, but that's just how it is. Because this is obviously, one of the things I really liked about this is that editor-wise, it's really simple to make because it's just these things on a grid, and then you can select them and move them around, and then the connections are all implicit based on their position. And then the inspector just shows whatever expressions are specific to the operator. So it kind of made sense in terms of not building a very complicated UI. But then, of course, once this scales, it's not very comfortable to work with anymore. And for 4K, I think the threshold for that is a bit lower than with a 64K, where we actually end up packing a lot of content. So my general sentiment about it is that this is too low level. And so now I'm doing the nodes on top of that again. It's kind of this crazy stack, but I'm liking where it's going. I like it technologically, so I'm pretty happy with it. Yeah, I think the operator representation there, I think that was also inspired by the old Farbrush tools, by old Werkzeug. And I'm pretty sure that's where the Loonies guys got those ideas. So if I pull up some earlier screenshots of Werkzeug, I think you'll see it's, again, same kind of thing. And I think this came about. I don't remember where I read it, but I think I read it was either Chaos or Riggs notes about it, and they were saying that I think they started with like a texture generator. And he just thought about like what's the simplest UI I can make for that, and it was this kind of stacking sort of UI. And then I think he just applied that to everything. And so I think a lot of tools have done this. This is a different tool. This is CCE of PySec or PASIC. I think it's PySec. Has a lot of, he has this like repository of demo tool screenshots. I should have pulled this up because this is a great place to look. Again, here's the 4K tool from Blueberry. There's a lot more of these. This looks unfinished. But yeah. So I think that idea was really pervasive, and I think that makes sense because it's a good balance of like a simple editor, and it still is very expressive. That said, I'm really happy to be doing something on top of that now. But yeah. I think this one looks like the brain control tool also has their music tool integrated in the same thing, which is cool. The Cocoon editor has similar sliders as what I'm doing now. Conspiracy's earlier tools look quite different, but similar ideas really. Their newer ones are of course a lot more sort of freeform, but anyway, I guess I've always felt like I've thought a lot about this stuff. But of course, I guess my ideas are still pretty derivative. But generally, I know what the editor is going to look like because it's such a pain in the ass to make any editor that I feel like I can't just do it that organically. Like in hindsight, it does feel organic, but it's been over the period of a few years, and each time I do a big new iteration, I've been very much focused on what I want that to be, and I won't start it until I figure it out. So yeah. I guess that's a really long answer to a simple question. But yeah. I'm just looking at this because it's fun. Oh, by the way, Alkama, congrats on the win. I don't know if I ever told you that, and I love the track. It was really cool. Some of these tools you can tell are like, this is definitely geared at 4K because you have the scene and post-processing, and it's very shader-oriented. So you literally have shaders and animation curves. I guess you have textures here too, so maybe it's a little more open than that, but it looks very much like this is designed for doing these kind of 4Ks. Oh, cool. Here's some ImGUI stuff for the Spectrals tool. Yeah, that demo had an insane amount of content. It was really cool. Right. Again, property editor, some kind of sequencer. Pretty cool. Yeah, Boise's Apex tool is pretty sick. Cables, again, similar stuff. You can also see that a lot of these people have, bigger and bigger screens, judging by the size of the shots. I mean, me as well. I'm normally working in a 4K screen, but of course I drop that down to 1080 when on the stream. So yeah, it's all pretty general, and I think at least in Logic Como, we've been really, I guess, successful in not making too much tooling when we haven't really needed it. I think we've been, like, I think we can make our demos a lot better, but I think they've been good enough, if that makes sense. I would consider our group to be fairly good so far. Yeah, look, it even has some of the older demotivation shots. These are pretty out of date, but it's still nice to see them here. But now, again, as I've said many times, need to make newer tooling. So that's what I'm doing now. Like, I'm glad we didn't do more complex tooling initially, and that I'm doing it now, I guess is my point. Yeah, new tool as well, huh? I forget that's also MGUI. Looks nice. I have actually considered going to MGUI for everything. But I don't think it's worth it at this point because I don't want to build a tool from the ground up. I'm really just adding a new editor to the existing tool. So I'll continue to do that. I love looking at all these shots though. I really enjoy this. This is kind of a cool curve editor. Kind of crazy. I love just how weird some of these are. Or at least look. Very cool. Anyway, yeah, I usually won't start working on tooling until I have a very clear idea what I'm doing. The exception to that has been specific components within the UI. I don't always know exactly what they're going to be, but I know how they're going to fit together roughly. And this is a good example of that. Like, I haven't known exactly how I want the properties to be exposed until I start seeing them and playing with them because it's more concrete for me to visualize. So that ends up being, I guess, a little more organic. But from a high level perspective, I knew I didn't start this node stuff until I knew exactly how it was, or at least I had a very clear idea of how it was going to work and fit together. Even though, again, small details like how the properties are going to be bounded, I'm literally figuring out now. So, yeah. So I think the way I have this set up too is a bit nasty. I'm not entirely happy with this, but I'm just going to continue doing it anyway. So I can always clean stuff up later. It's all, again, based around using this C API to expose things. Oh, I think I forgot to mention that too. I actually tried MGUI, at least the Rust bindings for Windows, and they kept bugging on me. I needed to figure out why that was, but at the same time, it's just like I don't want to spend time on that. So I'm hoping that will get fixed on its own before I ever decide to make that kind of switch. Until then, I'm just going to use what I already have and continue with it. But I will say that I probably would have started with that had I started again. But anyway. Yes. I want float 64 property attributes type. No, that's not it. What did I call this here? Did I call it property bounds? Yeah. Actually, we probably don't need this because it's going to be this. And these are where we fan out. So this is going to end up being this. Is that how I want to do that? Looks like I've been doing this kind of pattern. I think I'll do the same here. Naming these is always annoying too. You know, I could just start doing this actually. That's why I was doing this. Just need the node type and the property. Something like that. I feel like every time I write stuff like this, I scare off a bunch of potential demo seniors who want to make tools. But I actually don't think this is nearly as bad as some of the stuff I've seen in code in general. So we know we want to get that type, and then I guess what we can do is we can just expose, so like virtual double get node type float 64 property bounds, and then bound, for example. And these range lower and upper. So you would only, similar to using like a tag unit in C++, you'd only actually access these fields after you've checked the type. And it's just expected that the editor does that properly, which in my experience, being a single developer on this one tool, that's actually pretty easy to uphold. Again, would have loved to, like, again, if Rust had mature bindings for Qt, I wouldn't do any of this. But that's not the case, especially not when I started this. Enigmeta, I'm wondering how you do the translation of strings between Rust and Qt. I'll show you. So for example, you can see like here, the iNode model exposed the method to get a node name. So you give it the index of a node, and it will give you a string. And this string type is defined here. And you can see it has a string t pointer. So what I do is on the Rust side, that's where I decide to store everything. Because the thing is, it's easier to manage memory and everything in Rust, right? So I wanted, and it's also safer if you do that generally. So, or like, if I wrote the same amount of code to do this in C++ for the same amount of code in Rust, I would get more benefits from doing it in Rust. So things, essentially anything that Rust can touch should live in Rust, I guess is my point. So Rust owns all the strings. And oh, I have this string rs here. I haven't looked at this in a long time, but I'm just remembering it. So here, there's, for example, this string create. So if we look at I know I'm jumping around a lot, but I have to refresh my memory here. Right. So here's a method that will serialize something. So this will take a Rust string and give you a C pointer, and that literally takes the string and does into bytes, into box slice, puts RC around it, so it's reference counted, puts a box around that, and then gets that into raw. So it essentially just puts an RC around the UTF-8 bytes as a box slice, and then gets a pointer to that. It becomes a C pointer. So that's what I give to Rust. That's the pointer, or sorry, that's what I give to C++. So that's what this string T pointer is that pointer. And then if you get handle, for example, it'll actually give you this value, but that's only used in like these layers underneath. And then from here I can do like toQ string, which will get the length of the string, and then it will make a Q byte array and then get the bytes. Otherwise it'll create an empty one. So it's all that stuff. But essentially I'm just like passing pointers. And so then sort of going the other way is you can create a string from a Q string, which you can see here. And so what that does is that calls QString.toUTF-8. And so I guess the point is that I basically pass, I always work with strings, like if they're going across that boundary, I'm always going to do, get the actual UTF-8 bytes and then rely on the fact that both Rust can make strings out of a UTF-8 buffer and Qt can make strings out of a UTF-8 buffer. So that's what I use as the interchange, is that buffer and then length pair. So if you're creating a string from the C++ side, it calls this string create and it gives it a uint pointer to the UTF-8 bytes from the Qt string and then the length. And then in Rust, this string create here calls this UTF-8 to string with the buffer and the length. And then I think this copies it. Or no, maybe I make Rust own that. It looks like I do slice from raw parts, so I think Rust takes ownership of this. I actually don't think that's safe. Because you might use a different like deallocator for that. No, this is totally safe because I don't own the memory. This is just a buffer length pair from the slice, and then I call UTF-8 on that. Or no, 2vec will do the cloning. That's what this is. Yeah, so I actually don't take ownership of this at all. I just clone that data into a vector and then give that to string into Rust. So then I decode it in Rust, and then I have a Rust string. That's what this is. And it's an option because this can actually fail. So yeah, so if I create a string from Rust, then I do this box stuff. Otherwise, I go through here. So yeah, they're copied. I always do copies. So if you create it in Rust, then it will just, yeah, it always copies either way, which should be fairly inefficient, but at least at the scale that this is operating at, I've never even noticed it. This editor is pretty fast because they're small, I guess. But yeah, no, this is safe because it never takes ownership from different memory. It just will copy the string. So yeah. So then whenever I expose a function from this editor context thing that should return a string, I call this string serialize from a string, a Rust string object. So this does assume, of course, that whenever this calls like serialize, that serialize will return that pointer, and then eventually I expect string free to be called on that pointer, which will drop it again. And for that I use RAI in C++, and I always pass these by value. And there's a copy constructor here that will clone it, but the clone only clones the reference counted one, so it doesn't actually clone the data when you do this. Does that answer the question? I know that this was a lot, but that's basically it. Yeah, they're annoying, but what I decided was that the way I was going to do it was just always just copy the UTF-8 bytes. And it's been safe, which is nice. Fastest, definitely not, but safe and consistent. Yeah, sure. I would say it is. But it is annoying to have to deal with that. That's definitely true. And so most of the C API does very simple types. I think the string type is the only type, and context updates, it looks like. Yeah. Those are the only like higher level structures. Everything else will just pass in 32s or doubles or whatever. Yeah, I'm glad that helps. That's how I'm doing it. And I think also I could use like move constructors here, but this is before I learned about that move semantics in C++. So I just did the copy constructor and then clone, and it clones an RC, so that's fine anyway. I think passing around a vec2, for example, would be safe. I think that would be okay. Like generally those kind of tuples you could also represent, or I think what I would do for those kind of types is I would make one of those structs in Rust that you mark as representation C, and then I would have a matching struct definition on the C API side, and I would just pass pointers to those, for example, or put those behind RC and get the data. I guess that's probably messy. I'm not actually sure what the best approach there would be. But yeah, for these strings at least, it will put it in a box, then kind of like relinquish ownership to the C++ side, and then it expects that the C++ code will eventually call the destructor, which will do this free, which then has Rust reclaim ownership of that and drop it. And that's fine. Definitely more complex than doing nothing, but not more complex than that. Wow, really? I wanted to copy this or pull this editor here out for this one file. Really? And so I pulled this down to my desktop, assuming it would give me a new editor window and like break that out, but instead it copied the file to my desktop. That seems really dumb. Oh well, at least it didn't move it. But yeah, I think this is the whole interface that I need here. Now I'm just going to implement this because I know this is not going to be very difficult to implement. And I should also note that sometimes there's not a one-to-one correspondence with the API that I expose to the C++ code versus the actual data model. And sometimes that's annoying because things don't quite match up. And like if I refactor something, I don't necessarily update these. But sometimes that's kind of nice that I don't have to update these all the time. And this is actually one of the cases where at least the names don't reflect the exact structure here. Otherwise, I do like get node type, flow64 property, attributes, bounds, whatever. This is long enough as it is, and that's fine. At least it's clear enough what these are going to be for. And again, I'm the only guy working on this, so I can have a higher threshold for that kind of mess than I would otherwise. Like this doesn't feel hacky to me, just a little bit unsound, but in a way that doesn't bug me that much, if that makes sense. Okay, so in terms of implementing this, hey Freeful. Yeah, that's exactly it. Mixing mixing stuff. In terms of implementing this, we have to do that in a couple places. First of all, again, this is just the interface. So I'm actually going to, I think, make my editor take up the whole right side of my screen. And I'm going to move this out of your guys' view, unfortunately, but that's going to help me to see both sides. Hey, Olive. So this interface is implemented by, this interface is implemented by the editor context. And I don't know if I mentioned that, but the editor context is kind of like the God object. Like this is the thing that wraps the entire Rust context. And that's also why it's so big. But there's the C API part, and then there's the C++ wrapper around that. And then that's the thing that actually implements all these different interfaces to get the different parts of the data. So in here, you'll notice that all of these editors and everything, like a property type, it's all reflected here, except here, these are no longer abstract. So that's how that looks. And then we actually have to implement these. Now, normally this is the easy part. We just kind of go down the stack. And all these are pretty basic, so I'm pretty much just gonna do this. This. Oops. Really? Thought that would work. And yeah, this basically just returns stuff, so we're just gonna more or less copy what's up here. But of course, it's gonna be get node type float 64 property bounds type, and we give it the context type in the property, exactly what you see there. And this is going to be bounds bound, right? So, and as you might have guessed, we're also going to have to take all of these and go one level deeper. Which is here. And I know I just did this in kind of a messy way, but that's just me being a little bit lazy here. I think all of these were double. And I'm a bit inconsistent with when I use type defs and not. I really want to clean this up at some point, but at the same time, I never end up doing that. And it's fine. And then we need to actually implement this on the Rust side. So this I'll just go one by one. And again, I've made all this fairly symmetric, which again, some of this stuff could potentially be generated, but we'll see if I ever end up actually doing that. So this is property type. This is going to be this is going to return I32, which is why we type def it on the other side. And again, these sort of fan out in Rust. This one, all these next ones are going to be F64. We're just going to copy these names. You can see here, this doesn't have editor context because we fan out to an editor context object. Okay. And after this, then the compiler will tell us what to do next. So then we actually have to implement all these on the editor context object in Rust, and that's going to be the easy part, I think. Yeah, this shouldn't be too bad. So what I normally do is I go on the one I just forked, because I almost always fork this stuff. And I go to where the other one was, and then I just continue here. And again, here, I keep mostly the same interface. And here, nothing selected, Control D only matches the exact token. So if I just do this, for example, it will do that. I'm not sure what you mean by nothing selected. Oh, where the cursor's in. Oh, like that. Yeah, that's nice. That's a good tip. So here we'll do let type. And these are pretty basic queries. Thanks for the sub, Freeful. I really appreciate that. Yeah, indeed. I switched to VS Code. I've been using VS Code at work for a long time, for like a couple years, and then never switched at home. And recently I did. Yeah, no worries, Aaron. Thanks for the tip. Definitely one of those things that's hard to explain. Let's see. This will let the property is. I think I do this. Ooh, look what I just noticed. A typo that made it into a few places here, so we'll fix that. That's funny. Right, and so now we have match property.type. I'm really happy with the Rust integration here. This is the, I was just talking to guys on Slack about this today. Because I keep forgetting which one it is. It's not RLS, it's the other one. Rust Analyzer that I installed, and I'm really happy with it. It's not perfect. Like, there's definitely rough edges, especially when you have like a workspace with many Rust projects in it. It gives up pretty fast trying to find your cargo information and stuff, but yeah, overall it's really good. Yeah, I used RLS when I was using Sublime. I was happy with that too. Yeah, I like Rust Analyzer for this. I'm pretty happy with it. So yeah, this will be nodes, property type, float 64. And then here again, we'll have attributes, whatever. And then also this is going to be unreachable. And we're going to have a few of these kind of fan outs. So then we need to match dot bounds. So this will be nodes, property bounds. And I guess I'll just copy these. Actually, this is just the type. So I think I also need to make one of these like I did in the C API. I'll copy these again. Ugh. Typing, guys. It's hard. Something like this. Right, so there's one, I think. Oh yeah, we need to do this. There we go. So now these other ones are not implemented, but this one checked out okay. So I'm just going to copy this. Again, this stuff gets verbose, but that's kind of the only problem. And I'll bitch about it the whole way because even if this weren't verbose, I don't like doing editors very much. But that's fine. So now we actually only care about the ones where we have this bound field. And the other ones are going to be unreachable. And this is going to be double. No, F64 is called here. And so then we'll do, is it bound this? That's what we want. And I've been thinking actually about taking all these kind of queries and then moving them into the model rather than doing them at this level, which I may do, but we'll see. Again, it all depends on how much this ends up bugging me. This will be editor range. We need to make sure we get these ones too. So unbounded is also included in this. Okay. And then we need lower. And that's going to be actually bounded lower upper is the only one that has this. And then upper. You'll see me do a lot of copy paste for this stuff. And that's fine. Right, and now it type checked, and now the borrowed checker is complaining, and that's because I get attributes here, and I think we need to do ref for all these, which is a really easy fix. The reason I use a block of consts there is to make sure that I get the same values, but I don't think I actually need to do that. I think that's just a stylistic thing that I started doing 4 years ago and didn't stop doing, but an enum is probably better for that. There are areas where I use both, and I honestly don't know why that's the case anymore. I know why it is here, and that's because these operators are a more complex enum, so this is meant to match that, because I can't convert those to int in Rust. It's not a trivial conversion, so I can't do that anyway. And I guess that's the same for these cases too. But then at the same time, I could still have these in another enum, which is the same values, and then cast that. So I should probably do that at some point, make that change. And now the compilation takes a while because it compiled the Rust stuff, and all the C++ stuff changes because we changed this C API file. And yeah, but that doesn't take too long, and now it's there. I'm just going to run it, but of course we're not using this part of the API yet, so it won't do anything, but click around, looks good. Now we'll actually use this. So the nice part about this is that now this is the only part of this API we have to care about, is these new functions here. So we'll do that. So we'll go to the, where is it? The node inspector. I have the scalar node property editor. And this is where we want to actually start using this. So what I want to do, since these won't change, these are only going to change if the node definitions change. So the editor within its lifetime doesn't have to care about that. So I think what we're going to do is just cache all this stuff when this is created. So we'll make this type, and this will be the bounds type. And then we'll just have these same things. And I think I might do this too. Feels a bit silly to do it this way, but makes sense to me. So then in the property editor code here, we need to actually read those out. And again, you can see these to-dos, because again, this is driven by what the editor wants to do. So we'll just erase all that, because now we know how to do that. So for this, we'll do bounds type is, do we have the context here? Yeah, we do, because we have the inode model. So we'll do model, and then we actually need to do this crap. Bounds type. And for this, we need to give it the node and the property. And then we do the same for those other ones. Actually, we need to fan out on the type here now. So switch bounds type. Case. Unbounded, for example. Then we do, yeah, the same kind of thing. So this is another case where another way to have designed this would have been to like make a tagged enum for the bounds and then only transferred that over the C API and then done this fan out sort of at the lower like at the model level. And I think in hindsight, that might have been a better choice. But this is at least the way that I've done this fan out in this editor similarly. So I'm going to just end up sticking with it. But it's probably not the best design. But again, it's fine. Things don't need to be perfect here. They just need to be good enough for me to be effective. And since this is the only editor that's going to need these, as far as I know, for now that's the case, then we're fine. So then this is going to be bounds editor range is model get editor range. So we'll do the same thing for these other types. Where is that? Where did I put this API again? Did I close it? I probably did. And I think there's actually generators by now that will generate this kind of code for you. Like generate a C API for you, but at the same time, if I just live with this pain for a couple hours every time I have to do this, it gets done. And then it's done. And I just kind of live with that. And then just, again, bitch about it on the stream. There we go. So I'm going to run this. Again, this isn't used anywhere, but this fan out is actually going to have to be correct. Oops, I need to build it first. Otherwise, this is going to crash. It's going to hit one of those unreachable branches in the Rust side of the model. Oh. Right, because I still have these old bounds min and bounds max parameters here. Yeah, that we're gonna have to fix. It's in a couple places, isn't it? Okay, so maybe I just actually have to implement this. That's probably the easiest path forward here. Or what I could do is this too. Just to make it work for testing, which is my short-term goal. So I'm going to do that actually. Bang. Index is out of bounds even. That's a new one. 551. So that's here. Oh, yeah, I know what I did. This is dumb. You can see here, I gave it the node, but it's not the node. It's the type that I need. So do I have that in this editor? I don't. We need to do the node inspector will have it. We need to get the type here. Get no type like this. Yeah, there we go. So we at least know that they're being read, because otherwise this would have crashed. Yeah, so we need to actually calculate the bounds here. So I think I'm going to split out a little function here to actually get these bounds. And then here we need to figure out the range. So actually, I think what I want to do here is this. Yeah, no, this actually makes sense. We need to calculate a bounds min and bounds max based on these, and that is actually going to change depending on this type. And on the value in some cases. So I think actually doing it something like this is going to make the most sense anyway here. So if it's unbounded, then we have this editor range. And so we do bound min is that depends on if we're dragging or not, doesn't it? Because like I'm thinking bound min is the value minus the editor range. Oh, hey, Mentor. Thanks for the follow. I really appreciate it. Lost my train of thought here. Yeah, that's what it was. Because I want it to be like centered around the value. But this is not going to be correct because don't use value directly when dragging. So the idea is that if it's an unbounded value, I want this sort of slider in the editor to be like centered around what that value is. But this value here might not be the actual value because there's this drag start value. So I think I want to do this. The little center value is value, and then if, or we can do this, if is dragging, then I want it to be the drag start value, otherwise I want it to be value. We can even do const auto here, which I like, and then yeah, I think that's what we want for unbounded. And I was kind of thinking to do the same for like these bounded ones. But it's going to be slightly more complicated than that, I think. Because I want it to center around the value until the lower bound is like such that the lower bound is at the left side of the editor. That's what I want there. So I'm going to leave these ones for last. I think they're going to be the hardest ones. We can do this lower upper one because then this is easy. This is bounds min is bounds lower. I should probably rename all this too. Don't worry, Pascal. Can watch both. Whichever you choose, I won't have my feelings hurt. Yeah, I'm probably going to rename these min and max values. So that they're a little bit less ambiguous. But I'll make it work before I do that. There's a lot of like things I want to clean up in this code that I'll do on some day when I feel like it. Right now, it's not something I feel like it. But yeah, actually, a good way to do this is for bound lower, what we could do is we can figure out what the bound min is going to be, and then we can do bound max is bound min plus bounds editor range, for example. And we'll do basically the same thing here, except we'll do bound min is max minus that. And then what we can do is make bound min is, I don't know, isn't there like a Q max or something? I don't know if we need max or min. I need to think about that in a second, but we'll do the center value here. Minus so I know this is what I want, but I don't know if I need max or min here. And I think I want max because I don't want it going below this bound. So I think that's what I want. And then for this one, we can do the same here, except we do max, and we should do min here. And then we do center value plus, and then the bound. I think that's what we want. And I'm going to be real lazy here. Well, no, because these conditionals change too then. Yeah, I'm not sure the best way to write this yet. But essentially, this is what we want to do. We want to set these min and max values. And then you can see here, we kind of remap that over the width of the slider. Which we want to do like that inverse mapping here, where we have the position, then we want to remap it to the value, and also potentially clamp the value to those bounds. I think what I want to do, just test that this is starting to work, is find one of these unbounded values. Which I should have. Yeah, so for example, the scale or like translation is an easy one. And I want to just see that it does the centering stuff that I want. It may end up being kind of bogus because the way I've written the editor right now, though, but we'll see. But if we go in here, just look at the transform, you can see 0 is now centered here. Yeah, so when I drag, it still thinks it's like that wrong range. But you can see it always displays in the center there. It's actually not what I wanted. It doesn't look exactly like what I wanted. I'm a little bit surprised at that actually, because this is the center for the bounds. You know what? I'm going to hack this together for the slider too, because I think that'll make testing this a lot easier. Is there a Q point? Just an ugly way to get a tuple. Yeah, I'm actually going to use a stood tuple, I think. Because there's Q point F, but since I know that these are doubles, I want to just ensure that. So, problem is I don't use C++ enough to remember what this is. It's just tuple, isn't it? And actually, I think what I need to do is this. I'll do this using namespace. And then for the header, we need to include tuple because I need to make a private method here, which is going to be stood tuple. And then we have double. And I don't really know what we want to call this. We can say like calc slider bounds. It really doesn't matter what we call this. I don't really care that we do an extra query here. I guess we could require that we give it the value here, but yeah, I don't want to do that. Yeah, and this will be, is it called make tuple? Yeah, make tuple. And here we can just call min, and max, which I actually want to call these. Whoops. Lower, upper, which I like. And this is, I always get, which is ugly. Was there a different way to do that from the tuple? Yeah, that's fine. We can do I'm okay with this. Hey, Garrett Kelly. Yeah, because we need the bounds to do this remapping of the value. I can definitely make this code simpler, but I don't care right now. Yeah, so we figure out what the new value is going to be based on the bounds that we calculated in the position. And then we need to know if we actually want to, if we actually need to bound this or apply these bounds. So what we can do is this little deal. And what I think I want to do is this. If we have a lower bound and lower upper, then we do this. Try to apply the lower bound. And then we can do a similar, I'll still add a break here because that's conventionally makes sense to me. Or if it's upper or lower and lower upper, then we do this. Something like that. I don't trust that this is correct yet, but we'll try it. Ooh, new values, declared identifier 125. Is that not this? Legal case 119. Oh, whoops. Is dragging is undeclared identifier. That's 168. Is dragging, I thought was, it's this. Just gonna copy this for now because I'm lazy. Calc slider bounds must return a value. Does it not? Oh yeah, return. Wait, did that crash the compiler? It totally did. Whoops. That's funny. Yeah, so now you can see these are all centered. That still doesn't move how I wanted it, but we do, this is unbounded. Although the value is going all over the place, so we definitely fucked something up there. So yeah, this will need some work. It works well in this bounded case here. That's nice. And here, look at this, unbounded up here. Indeed, we can go past that bound. And then we let go and it's centered again. And now it won't let us to the left because it doesn't calculate that bound correctly. So we got to figure that one out. Oh, this got finicky. But it's starting to work. I think it's actually because these... Yeah, these bounds here don't necessarily represent... Because these are like the value... These represent the... how do I explain this? These should actually represent what I wanted them to, which is the bounds. The bounds for the value sort of in context of this slider editor. So it should actually be okay to... Did I enable word wrap on accident? I do not know how to use this editor at all. This is great. Okay, now it's back to normal, whatever. Let's see. Like, it should make sense to me to calculate these bounds and then calculate this based on these bounds. Like, this makes sense to me. And it's totally possible that this goes out of the range here, which is fine. And we clamp it to... Oh, this is wrong, for sure. This clamping is wrong, because this is not these bounds. Because, again, that's the bounds... Like, okay. We actually need to do this. So for lower, we need to say if this is less than bound. Bounds bound, I think I called that. Yeah, you guys are the best rubber duckies, by the way. Appreciate that. This might fix the bounding thing, but I think it won't fix all of our problems. So if we go to one of these ones in the material that emits it, where we can go way beyond this, like this makes sense to me. And this looks correct, because I think we had the range be 1, so we should hit 1 here. We can't go below 0, but if we like go below here, that is still mapped there. If we do this, this should be the center now. And we should be able to go below, except not below 0. And that totally seems to work. So yeah, if we stop in the range that's within this editor range, then that's actually where the slider will stop. Otherwise, it's going to center around the value. And we can go beyond there within those bounds. So this actually appears to work so far for this slider. For something like translate, this goes up to 160 here, and then we go back, and now it's completely bogus. So whatever's happening with these unbounded ones is completely ridiculous. But at least it worked for these emissive ones. That's pretty cool. Yeah, that's another thing I want to do, Freefall. I think I mentioned that at the beginning of the stream. I also want to add it. Want to add a feature where you double click one of these and then you can type it in. But I wanted to do that after getting this to work, so that we can extract the bounds to correctly enforce. Because it still might be that, again, with these properties that are bounded, that either have like a lower or upper bound, or both. But if it's like big, then what we want to do is like I want to do different bounds checks, and I want the type in editor to also do the same bounds checks. I guess is the best way to explain it. So I want to make sure those work by first implementing it with the slider editor that I already have, and then once that works, we can do everything else. I think that's what I wanted to say. Anyway, this unbounded one is totally wrong. And I'm not really sure why, actually, because... Oh yeah, because I use value here, not center value. That'd do it. That's probably the whole bug. Because I want it to center around where you started dragging, not where the actual value is. So now I think this makes more sense. Like this is at negative 0.86, and if I go way up and way down and do all kinds of crazy stuff, then when I go back to the center, it should be about 0.86. But I can like drag this more and more. And this is going to be really useful because here's my cube again. Oh yeah, and of course my emissive goes more than 1 now, which is fine. So yeah, I'm rotating and I can go like totally out of bounds here. Which this is perfect. This is exactly what I wanted. I can do negative scale too, which is something that I wanted. Look at this, guys. This is a proper tool now. Not quite, but it's getting there. And again, if I want to take one of these emissive ones, I can't go below 0. So yeah, this is great. I'm very pleased with this. Again, these are bounded correctly. And I'm just going to have to assume that the upper bound works correctly, which I haven't tested. You know what I could actually do is I could make, for example, translate x could be upper. Bound, and we'll make that, we can just keep it as 10, for example. We can test it this way. Oh yeah, we also need an editor range there. So we'll do editor range 1. Just to test. But then it's exciting because then we have proper bounds on these, and then I can work on doing the double click editor next. But that won't be today because I've already been streaming for 2.5 hours. So I'll cut off the stream after pushing this stuff. But yeah, you guys can definitely see why this stuff takes a long time. Even if I had spent less time on the plumbing, I would still have to like debug all this stuff. Which can be annoying. So I did wait, what did I do? Translate X was the property I changed? Yeah, it was. So now this, we can go as down as low as we want. You can say go past 10. We can't go up past 10. I'm going to have to do this in a couple actions because of my window. And there's 10. You can see now, this is like the upper bound. So if I let go here, it should be about the same. I can kind of drag the value like that. And it's clamped at 10. But again, I can go anywhere else. Perfect, that totally works. So I don't feel like this code is done. I want to do some cleanup of it, but it's certainly done for now. Thanks, Meta. I really appreciate that. I'm glad you're learning stuff. It's fun for me too, because I just like sharing, so it's definitely working for both of us then. It's good to hear. Yeah, here you see the to-do on the double-click event, which is where I'm going to implement the other stuff. But yeah, for now, I think I'm happy enough with this. Oh, it definitely does freefall, which is great. Makes me get my head straight. Like, I definitely feel that, like, when I'm streaming, I'm less productive than when I'm not streaming. But I think in the end, it works out really well because it keeps me focused. Like, it keeps my head kind of in this game because I'm explaining things and showing things. And also, like, there are cases like this where it's nice to be able to rubber duck everything that I'm doing. So I think it's nice to do this once a week. I wanted to start streaming twice a week during this whole social distancing thing, but I just can't seem to get myself to do it on most Sundays. This is cool. Like, I think already when I have this editor finished, and then things for that is going to be double click and then some cleanup. Then this is going to be obviously super useful. And after that, I'm going to need like a color picker kind of editor, which I'm going to end up having. And then see, this is the best part, by the way, that I just like sit here and play with this. That's the dream, you guys. That's why I'm doing all this. You know, I'm also probably going to add a note to like reset this or something. I don't know what interaction I want that to be, but I'm going to add a note to make sure that I look into that. Maybe middle click or something. Or control click, I'm not sure. Yeah, that'd be cool, Code Trotter. Maybe I can do that. Oh, backspace while hovering over a slider. That's probably a good idea. Because I use backspace and delete elsewhere in the tool, so I think that would make a lot of sense. And I do also think that it's like... It's kind of the right interaction. Like, semantically, I want to clear a value. Because it is possible for these nodes to not actually have values for these properties in some cases. Oh, I'm noticing a small thing that I guess once this is converted to integers, sometimes it's a little bit off by 1 pixel. Maybe I don't care about that. I do like this, that you can kind of just like bump the value like this. That's kind of cool. And I might even do like shift to do like a small range or something. Who knows? But yeah, and I might end up doing gizmos for editing some of these properties too. At least when like you click the transform, or maybe you click an entity, it would bring up that kind of gizmo. Not sure though. But yeah, it's even though it's verbose to set up property editors like this, I'm not going to have that many types of properties, and it's just a really good investment to make sure that these are solid, because we're going to be relying on them for a long time, I think. Cool. Anyway, I think I'm done for today. Made some good progress, so thanks guys for hanging out, and I'll see you next time.